So now come to question number 12, exercise 1, phase 2, ellipse, mathematics. Find the equations to the normals at the ends of lattice rectum. So let us see this. So this is the focus. This is lattice rectum. End of lattice rectum, suppose you call it A. So this will be A comma B square upon A. This will be A comma minus B square upon A. Total length of lattice rectum is 2B square upon A. Now I have one very important point is there. What is given? If this lattice rectum passes through the end of one minor axis. So normal will not pass through this. Normal will pass through this minor axis. Suppose normal here is passing through this minor axis. This is 90 degree. So this is 0 comma minus B. So equation of normal we will write A square x upon x1 minus B square y upon y1 is equal to A square minus B square. This is a equation of normal at any point x1, y1, where x1 is this, y1 is this. So A square x, x1 is A minus B square y, y1 is B square upon A. So A will go to top is equal to A square minus B square. This will cancel. A will cancel. So AX upon E minus AY is equal to A square minus B square. Now, as per the condition, this is passing through 0 comma minus B. So 0 plus AB is equal to A square minus B square. So dividing by A square, so we will get B upon A is equal to 1 minus B upon A whole square. So we can write this B square upon A square minus 1 whole square is equal to B square upon A square. Now, we have to find relationship between eccentricity. So what is the eccentricity? Formula A square is equal to 1 minus B square upon A square. So 1 minus B square upon A square. So from here B square upon A square is equal to 1 minus E square. Put these values. So this will be how much? Minus E square whole square. So it will become E4 is equal to B square is 1 minus E square. So E4 plus E square minus 1 is equal to 0. This parabola must satisfy this eccentric equation of eccentricity. So thank you.